Number 4, what are the x-intercepts of the following quadratic functions? Okay, the x-intercepts are also called the zeros of the function, aren't they? And to get those, you have to set the quadratic equation equal to 0. Okay, one way to get the answer would be to factor. Let's try to factor this one. Okay, so we have the factors of 7, which are 1 and 7. Okay, and then to get the 3, we're going to write the 1 and 3 over here, draw the 2 blanks. We want to subtracting it 4. So I could put the 1 and 7 in here, subtracting it 4. Put 7 here, 1 here. 1 times 7 is 7. 3 times 1 is 3. 7 and 3 do indeed subtracting of us 4. Put an X in the middle of your 4 numbers. Put 0 equal and draw your 2 parentheses. This negative sign drops. This means they're going to be different, plus. Okay, now then 7's larger than 3 and 7's right here. The 3 and 7 go in the first parentheses. So 3x minus 7 goes here. And in the other parentheses, I'm going to have x plus 1. Now then, to get my zeros, I'm going to split this up. 3x minus 7 equals 0, and x plus 1 equals 0. Okay, on this one, we need to move the 7 across. I'll get 3x equals 7. Then I'm going to divide by 3. X would equal to a positive 7 over 3, wouldn't it? On this one, I'm going to subtract 1 and get x equal negative 1. So x could equal a positive 7 over 3 or a negative 1. So on this problem here, x would equal a 7 over 3 or a negative 1. Those are the 2 zeros. That's where the parabola will cross the x-axis. Now on this one, we'll use a quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we know that a is 2, b is 9, and c is negative 11. Let's get the discriminant first. So b squared minus 4ac. b is what, 9? So I'm going to put 9 in parentheses minus 4 times 2 times negative 11, aren't I? 9 squared would be 81. I would just punch this in the calculator since you have a calculator. Remember, we're getting the discriminant, aren't we? Which is the number inside the square root. A negative times a negative is a positive. 4 times 2 is 8. And 8 times 11 is 88. And if you add this up, you get 169. That means we're going to get 2 roots, aren't we? Because the discriminant is positive. So I'm going to replace the b squared minus 4ac with 169. So I'm going to go down here, write my negative, parentheses, b is 9, plus or minus the square root of 169, all over 2 times, and a is 2 in it. Okay, the square root of 169 is 13. This is going to be negative 9 plus or minus 13, all over 2 times 2 is 4. So this right here turns into negative 9. The square root of 169 is 13, and 2 times 2 is 4 in it. Now then, this is going to turn into negative 9 plus 13 divided by 4, or negative 9 minus 13 divided by 4. Okay, and we're going to go down into the next problem here. Negative 9 plus 13 would be 4. 4 divided by 4 would be 1. That's one of my roots. Or negative 9 minus 13 would be negative 22 over 4. And if you punch that in on the calculator, it'll simplify to negative 11 over 2. So my 2 zeros on that one are 1 and negative 11 over 2. So you could either factor and get your your roots, and remember these are the zeros of the function, or where the parabola crosses the x-axis, or you could use a Pythagorean theorem.